Okay, this is 7.3 homework. The first problem wants us to solve this trig equation and give the answer between 0 and 2 pi. All right, so let's go ahead and solve this. I'm going to rewrite this as 2w squared minus w minus 1 equals 0, just to see that this is a quadratic. And we can factor this. It factors into 2w and w here, and then minus 1 and plus 1 here. Now, let me rewrite the sign back in there. So it's really 2 sine of t plus 1 sine of t minus 1 equals 0. We're going to find out where the first part is 0 and where the second part is 0. The first part first, if I set that equal to 0, and I subtract 1 and divide by 2, I get sine of t equals negative 1/2. So we're looking for that in the unit circle. Where does the sine equal negative 1/2? Well, that's here and here at 7 pi over 6 and 11 pi over 6. Now I'm also solving this part here. Set that equal to 0, so we're looking for where the sine of t equals 1. The sine of t equals 1 at one spot, and that's up here at pi over 2. So they say pi is already here, so just use the fraction. So just use 7/6, 11/6, and 1/2 for my answers. Okay, the next problem wants us to find angles between 0 and 2 pi again that solve this equation. So this is an easy one. It's kind of solved for us. We're looking for where the y value is 1/2. The y value is 1/2 here at 30 degrees. This angle would be pi over 6. And then this angle over here, where the sine is 1/2 again, is 5 pi over 6. So those are my two solutions between 0 and 2 pi separated by a comma. All right, the next problem wants us to solve this equation right here. It wants to enter our answer like this. So let's just start solving it and see where it goes. First of all, I'm going to factor out a cosine. When I factor out a cosine, I get the sine of x minus 2 equals 0. Now I'm solving both parts of this, where the cosine is equal to 0. The cosine is equal to 0 at pi over 2 right here, and also 3 pi over 2. And it says your answer like here is, so it looks like my answer is going to be a multiple of different answers. So my answer for where the cosine is equal to 0 is pi plus any increment of pi, which would be pi times k. I'll use k instead of n. So my answer is this pi over 2 right here, plus anytime I add pi, I get to another answer. So that's my answer so far. Now this part right here doesn't have any solutions because the sign is never equal to 2. The sign fluctuates between negative 1 and 1, so there's not going to be no solutions that come from that factor. So that's my answer right here. Let's see how they wanted me to enter it. They say b k pi, so in which case a is pi over 2 and b is 1 because I just want k pi, which is what I have right here. Next problem is even easier. There's no solutions, and the reason why is because we know sine fluctuates between negative 1 and 1. There's no way I can get negative 50. It's sine of some angle plus another 8. It doesn't matter though. There's no sine of any angle that equals any number outside of negative 1 to 1. All right, and the last problem says find all the solutions to this equation right here in the interval from 0 to 2 pi. So I'm going to multiply both sides by the tangent, in which case I get the tangent squared of t equals 1. And now I'm going to square root both sides, so I get the tangent of t equals plus or minus 1. So I'm looking on the unit circle, this is a tougher one, to find out where the tangent equals plus or minus 1. Now that happens whenever my cosine and sine are the same, because here, for example, square root of 2 over 2 comma square root of 2 over 2, that's where the sine and cosine are the same. And when tangent is really sine over cosine. So I want to be able to divide sine over cosine, which in this case would be square root of 2 over 2 divided by square root of 2 over 2, which would give me 1. So that point would work. This point over here would also work, negative square root of 2 over 2 comma positive square root of 2 over 2, because when I divide sine over cosine, it would give me negative 1. So, all these corners work right here in the interval from 0 to 2 pi. So to write all those, I would have pi over 4, comma, 3 pi over 4, as well as 5 pi over 4, and the last one would be 7 pi over 4. All right, hope this helps.